Bonjour et ça va? Welcome to the channel of the MaffsGuru. Yeah, I have no idea where the French accent either, but the moment just passed. It came over me, and yes, it's now passed. Welcome to today's little video on polygons, aimed at year 8. Now, if you're not year 8, don't worry about it. There's bound to be stuff in here that you may not know. Actually, there's stuff in here the year 10s don't even know. So, what am I going to deal with? Well, before we do that, do you see that red arrow that's pointing over there? Well, yeah, that's a sort of, can you help me out by subscribing to my channel? Yes, just click that little button and YouTube will add you to my growing fan base. And by that, I mean all 7 people who are watching in the United Kingdom. Hi guys, welcome, pleased to see you. In fact, most of those are undoubtedly my parents. If you can get out there and actually tell your friends, circulate the link for YouTube to everyone you know, I would be deeply, deeply grateful. Now, what I tend to do at this moment in time is recap the learning, but there's not too much to learn. If you look above, it looks like there's lots of things and it's been highlighted by a red arrow now. But we're basically going to know, what is a polygon? What's a regular polygon? How to find interior and exterior angles and use a little bit of funky algebra to help us do this. So let's not waffle too much. We're going to go back to previous videos. Now, I'm building this course sequentially. And so I already know there are videos relating to the triangle angle sum and quadrilateral angle sum. By what do I mean by that? Well, basically, long story short, there is a triangle. How many degrees are there in a triangle? And if you're yelling down the YouTube channel at me and saying 180 degrees, then yes, you're absolutely right. Everyone knows that. I think we learned this back in junior school. And then we go the quadrilateral angle sum. And how many is in that? 360 degrees. But do you know why? There's lots of different whys. Most people tend to go, because there's 4 right angles in there. And 4 right angles make, 360 degrees. But what about other polygons? And you're going to say, polygon? What's a polygon? Now get ready, this is a really bad pun. Look behind me, what do you see? Yes, it's a missing parrot. I worked for minutes on that one. I did that with my kids today and they were like, what do you mean? I don't understand. I'm like, Polly the parrot, polygon, the parrot's gone missing. Yeah, anyway. But what is a polygon really? Well, it strangely enough comes from Greece. And don't all the good things come from Greece? Yes, I believe so too. Hi, for those of you who are watching this in Greece, or in fact of Greek descent. You'll probably already know this, but when I looked it up on Google, what comes up? It's a plane figure with at least 3 straight sides and angles. Now, interestingly there, the important point here is straight sides. Happy with that? Yes, good. And I was like, where does it actually come from? And those of you who are at Greek school will undoubtedly say, it's actually from this word here. Now, with all due respect, I have no way of being able to pronounce that. But what it means is, from what I understand, many and angled. And I do know gonias means angled. Yay, my Greek is as bad as probably every other language I speak. But so now we know what a polygon is. It's important to know that it's something with straight sides and angles. Now, not straight angles, but straight sides and angles inside of it. And generally speaking, at least 3. So here are some examples of some polygons we've already met. Now, one of them was a triangle. And it doesn't matter what triangle we draw. And there's lots of them. Isosceles, equilateral, right angle, scalene. Every single triangle known to man has 180 degrees inside it. Now, a triangle has 3 sides and the angles inside are 180 degrees. Now, you're going to probably say, why are you writing that there? And I'm going to say to you, because it's all going to be important in just a moment. Then we get a quadrilateral. And if you remember, a quadrilateral is how many sided shapes? There's 4 sides. And if we split this into triangles, the most triangles I can get in there is 2, and I'm going from 180 degrees in each triangle, gives me 360 degrees, which just so happens to be 180 times 2. And you can say, well, all right, fair enough. I'm going to go back to this one here, and I'm just going to put this one here is 180 times 1. Now, I'm about to build up a pattern, and those of you who've done patterns in algebra will hopefully start to see where I'm going with this. Well, quadrilateral, then we get to a pentagon. Now, pentagon is a 5-sided shape. Here is my 5-sided shape. How many triangles can I split this into? Well, 1. Let's make this a dotted line. 1 and 2. Now, undoubtedly, there's people out there going, no, I can split that into way more triangles. There's small triangles and big triangles. And what I'm saying is you have to be able to connect one vertex to other vertices and create these triangles. There's obviously rules to this. You can't just randomly throw in hundreds and hundreds of triangles. But if I choose one vertex and connect it to all of the other vertices, the most triangles I get is 3. Each of those has 180 degrees. And so, with a 5-sided shape, I have 3 lots of 180 degrees. Now, what's 180 times 3? Well, quick pencil and paper calculation, 8, 16, 24 is 540 degrees. And you're going to say, but hold on a moment, you've swapped the order in which you've done this. I know, I'm trying to be clever. And let's do one more, a hexagon. How many sides are there in a hexagon? And these are all polygons, by the way, because they are straight-sided shapes. 1, 2, 3, 4, 5, and 6. So there's 6 sides there. Dreadful drawing. But choose one vertex and let's connect it to all other vertices and see how many triangles I end up with. Well, there's 180 there, 180 there, 180 there, and 180 there. So hexagon's got 6 sides. And it seems to be that we've got 4 times 180 degrees, which is 720 degrees. Do you start to see the pattern? No. Well, you'll come to it now. You need to know all of the different polygons up to, well, about a 12-sided shape. Yes, so hexagon, then there's a septagon, an octagon, a nonagon, a decagon. Now, what is an 11-sided shape called? Well, funnily enough, I had to look this up. And it's an undecagon. I'm serious. A 11-sided shape is called an undecagon. I have no idea. Sure, because when you don't you undo? But anyway, what actually it means is in Greek, and I've learned this as well, comes from uno, which is 1. Dec means 10. And agon comes from agonia. So it's 1 plus 10 sides, 11 sides. Yo, love the Greeks. Respect to you, Greece. And a 12-sided shape is a dodecagon. Now, don't say dodecahedron. Whenever you put hedron on side, yes, it means a 3-sided shape. And agon, so a polygon, actually means a flat, well, a 2-dimensional shape. So let's go back. All right, so when we had a triangle, we had 3 sides, which gave us 1 times 180 degrees in terms of angles. When we had 4 sides, we had 2 times 180 degrees. That was a quadrilateral. When we had 5 sides, we had 3 times 180 degrees. And when we had 6 sides, we had 4 times 180 degrees. And do you see the link? Well, if this is my number of sides, how do I go from 6 to 4? From 5 to 3. From 4 to 2. And from 3 to 1. Well, it just so happens, ladies and gentlemen, you take the number of sides and then take away 2. And that's actually it. So the internal angle sum, that's the number of angles inside my shape, is given by the number of sides minus 2. And I'm going to put this in bracket because that's really, really important because we need to do that first. Then I'm going to times that by 180 degrees. And believe it or not, that is my general formula. I can now use this formula to find the angle sum of any number of sides on my shapes. Like if I say 20-sided shape, I can use this to find how many angles are inside that. So let's recap a little bit of this algebra. Yes, now algebra is basically just a way of putting one number into an equation to find another. So it says, if I know one thing, can I find something else? And I'm going to go back and I'm just going to write AS as my angle sum is equal to n minus 2 times 180 degrees. How many things in there do I not know? Well, obviously this one here, I don't know my angle sum and I don't know the value of n. But the good thing is, if I give you the value of n, if I say for you, example, n is 5, I can put that into my equation and work out what the angle sum is. So let's do that here. Find the interior angle sum. Now, while I've used the word interior, all that means is the angles inside the shape. So the interior angle sum is equal to n minus 2 times 180 degrees. Now, do they actually tell me n? What is n? Well, n stands for my number of sides. If you go back to the formula here, this here, yes, is the number of sides I had, and the way I got to do that was take away 2. So my number of sides. Do they tell me that? They do. They say it's 8 minus 2 times 180 degrees. Well, I know how to do this now. I've got some brackets. 8 minus 2 is 6 times 180 degrees. Now I could jump to my calculator, but I'm not. I'm going to do it longhand. 180 degrees times by 6. 6 zeros is the 0. 6 times 8 is 48, and that is 1080 degrees. So I now know that a polygon with 8 sides is going to have all of those angles inside add up to 1080 degrees. Whoa, massive. And then we move to actually being able to do things backwards, because remember, in maths, what you can do forwards, you can also do backwards. So I'm going to go and I'm going to write my formula out again. I've got my angle sum is equal to the number of sides minus 2 times 180 degrees. Right, now, this is we're doing it backwards. And the way I know that we're doing it backwards is they're actually giving me the size of the angle sum. They're actually saying, find the number of sides. So in my formula, I'm now going to find the value of n. Right, well, with algebra, what do? We put the angle sum underneath the thing that in the formula that stands for angle sum. So 1440, that's the sum of the angles, is equal to n minus 2 times 180 degrees. Now, don't worry about n. Remember, that's what we're trying to find. So how do I do this? Well, I want to get rid of this times by 180. How do I get rid of it times by 180? I need to divide both sides by 180 degrees. So 1440 divided by 180, that means that disappears, gives me brackets n minus 2. Now in that situation, because there's nothing left touching those brackets, I can actually get rid of my brackets here. And you're going to say, well, I can't do that in my head. And you know what? Nor can I. So I am going to load up my calculator and I'm going to 1440 divided by 180 gives me 8. Yay! So 8 is equal to n minus 2. So a number, take away 2, gives me 8. Hopefully, just by looking at it, we know that n is equal to 10. Another way of doing this is using algebra. And if we said 8 is equal to n minus 2, how do I undo a minus 2? I add 2 to both sides, which means that disappears. The n is left on its own, and 8 plus 2 is 10. Now, generally speaking, we don't write 10 equals n in maths. We write n equals 10. So long as the equal side and the numbers swap over, we is good, is we not? Now, knowing this formula is just awesome. But I get a question that says, well, what about convex and non-convex shapes? Are the angles inside different? Well, let's look at triangle. Sorry, let's look at a quadrilateral. Here's a quadrilateral. How many triangles do you see? 2. So 180 degrees, 180 degrees gives me 360 degrees. Hopefully all of you would agree that this is a convex shape. Convex is where all the arrows, all the angles are effectively pointing out of my shape, yeah? Another way to think of this is they're all less than 180 degrees. A non-convex shape is where one of the angles is bigger than 180 degrees or points into the shape. And what I mean by this is, let's imagine this shape here. Now I love this shape here because it's the Star Trek communicator. Yeah, sadly I don't have my Star Trek, anyway, fine. Same thing, I choose a vertex. This here is still a vertex and I try and connect it to all other vertices. Vertices. How many triangles do we see? Exactly the same, 180 degrees and 180 degrees. So the angles inside of there still add up to 360 degrees. And that means that this angle here, added to this angle here, added to this angle here, added to that angle there, is still 360 degrees. So whether they're convex or non-convex doesn't actually matter. Next email I got, and I get loads of emails about maths questions. Not. If you've got a question, by the way, leave it in the comment below, leave it in the messages below. I'm more than happy to answer. But they say, what's the difference between a polygon and a regular polygon? Well, not wanting to crack the parrot joke again, so we'll move on. Basically, one word. Lol. Do you get that? Regular? No, anyway. The difference is actually the size of the angles. Here is a polygon. It's a 5-sided shape. Yep. Are all those lines exactly the same size? No. Looking at my diagram, it doesn't appear they are. Would you say that all of the angles here are exactly the same size? No. So in this situation here, this is just a polygon. Right? It's a bog standard, thank you very much, polygon. if, and my diagram, by the way, ladies and gentlemen, will not look very good at all. It doesn't. So let's try that again. Is this going to work? Not at all. If all of my sides are the same length, and the great thing about maths is I can add those little marks that basically say, although it doesn't look to be the same, they are in fact the same. If all of the sides are the same length, this will mean that all of my angles inside will also be exactly the same size. And if that's true, then this here is called a regular polygon. So the word regular means that all the angles and all the side lengths are the same. And by that I mean the angles are the same and the side lengths are all the same. So obviously a square, believe it or not, is a regular polygon because, yes, all of my angles in here are 90 degrees, and we know that for a square all the sides are the same length. Right, knowing that, we can start moving on to some pretty funky maths. Now, what about interior and exterior angles? And there seems a lot of language here, doesn't there? But the point of it is you just need to know about interior and exterior. So if I draw a polygon, and again, I've got a nice heptagon there, five-sided shape, 1, 2, 3, 4, 5. Interior angles are obviously the angles that are inside my shape. So what are exterior angles? Well, as it turns out, exterior angles are angles on the outside. So changing my pen color, if I was to extend one of the lines perfectly out, then this angle here is called an exterior angle. Why? Because it's outside. So all I've done is I've taken this line here and I've made it longer. Now, how do you think we find that exterior angle? Well, if we know this interior angle, we know that this here is a straight line. And so angles on a straight line add up to 180 degrees. So if this was 60 degrees, then I would know that was 120 degrees. Write it straight down, yeah? Or I could use some algebra. And likewise, this line here could be extended out here, and I could find this angle here. If that was 70 degrees, then I would find out that that was 110 degrees. Why? Because they are once again on a straight line. And I can keep extending lines, and I can keep making them larger, and all of these angles outside just so happen to be exterior angles, because they're angles on the outside. Now that's pretty funky, don't you see? And again, this shape here is just a polygon, and it's just a pentagon. It is not a regular pentagon because those sides are not the same and those angles are not the same. So if I wanted to find the exterior angle, so let's do 1, 2, 3, 4, 5 again, and let's extend this line along here. If I say that this angle here is 120 degrees and I say find the value of x, do you see what I've done? Again, it's just a straight line. Wherever I can see this straight line, these two angles here must add to make 180 degrees. Yay, they're supplementary angles basically. So what would I be able to do there? Well, I would say that 120 degrees plus x is 180 degrees. Take away 120 from both sides. Gives me the x value of 60 degrees. Now this stuff is freaking awesome. Yes? Happy about that one? So that's how to find an exterior angle using a single extended line. But what about exterior angles all around a shape? Now, if they've told you all of the angles inside, well, the fact of it is we could find any individual exterior angle. But I want to go back to a regular shape. And this stuff tends to, you're either going to get this or you're not. So I'm going to go to a regular shape here. And in this case, it's a regular pentagon. How is it a regular pentagon? Because my little lines tell me it is. So I now know all the angles inside are exactly the same size. And there's numbers of ways I can do this. But what about if I want to find just one of these angles here? Now, as it turns out, if I was to extend all of these angles, making all of these lines go longer, and I'm going to color these in to differentiate them as exterior angles. What I want you to ask the question is, what do you notice if I travel around my shape? Oh my God, I've just said around. It means I've traveled a circle. Well, if I travel a circle, what do I know about the angles in a circle? Well, I know that all the way around a revolution is 360 degrees. Now, if the inside angles here are all the same size, what do you think the outside angles are? They're all the same size too. So I have 1, 2, 3, 4, and 5 angles around the edge of this shape that seem to form a circle, and they're all the same size. So I now know that 5 times x is equal to 360 degrees. You can say, whoa, where'd you get x from? Well, I'm just going to call each of these angles having a size of x. So x plus x plus x plus x plus x is 360. 5x's are 360. I want to get rid of that times by 5. So x is 360 degrees divided by 5, which gives me a grand total of, firing up my calculator, 360 divided by 5 gives me 72 degrees. And we can use this on any shapes, any pentagons, any whatever. So here are some examples taken from the Cambridge Essential textbook, which is a resource I'm using, and it is freaking awesome. So firstly, question number 1 says, find the size of the angle marked A degrees. Now, this one in itself could be relatively easy, because you just look at it and say, oh, well, I do 110, following the previous working out, I do 110, try that one again. I do 110 degrees plus 95 degrees plus 115 degrees plus 90 degrees plus A must equal, and now there's the question, what do they all equal? Well, it's not a quadrilateral, so it's not 360, it's not a triangle. Oh, I have to go back and find how many angles are inside first. So I'm like, absolutely. You need to do a second calculation. Or rather, you need to do a first calculation. So I know that the angle sum of that is given by n minus 2 times 180 degrees. How many sides has it got? 1, 2, 3, 4, 5. So my angle sum is 5 minus 2 times 180, which is 3 times 180, which is 540 degrees. So now I can put 540 degrees there. Right, so let's do some funky maths. 110 plus 95 is 205 degrees. 115 plus that is 100. Oh no, try that one again. Is also 205 degrees plus A is 540 degrees. Adding those together gives me 410 degrees plus A is 540 degrees. Take away 410 from both sides. 540 minus 410 gives me A as 130 degrees. And the crowd goes crazy. And here is a second question. Now we're throwing in some obligate with it. And you can say, obligate? What's obligate? Algebra. It doesn't make any difference. So the first thing we need to do is find out what is the angle sum for this shape. That's going to first thing for all of the questions I'm going to look at. 1, 2, 3, 4, 5. Well, as it turns out, there's 5 sides again. So I'm just going to redo the calculation. Angle sum is n minus 2 times 180 degrees. Now, those of you who are watching and I teach, yes, this is the working out I want to see every single time. So 5 sides minus 2 times 180. Work out 5 minus 2 and times it by 180 gives me 540 degrees. I'm going to do a dotted line here now to say, here's another part of my calculation. So I now know if I add all of my angles together, I get 100 degrees plus 90 degrees. Are you sure? Because that there is a right angle, so it's 90 degrees. Plus 95 degrees plus x is equal to 540 degrees. Don't think it's 360 degrees. You have to work it out. So doing some funky simplification, that's 190 degrees plus 95 plus 2x is 540. Simplify this down again. It gives me 285 degrees plus 2x is 540. Take away 285 from both sides. Gives me 285, and I'm going to use my calculator just quickly. 540 minus 285 gives me 255 degrees. How do I get rid of that 2? I'm going to divide both sides by 2, and so x becomes 255 divided by 2, which is a grand total of 127.5 degrees. And you're going to go, It's got a decimal. Do I round it? No, you don't round it. Leave it. 127.5, 127.5. It's awesome. And there, ladies and gentlemen, is the end of my lesson. Yes, we have seemingly covered quite a lot. We've done a bad pun about parrots going missing. We've looked at polygon means basically a three-sided or more shape that's got straight sides, even though my diagrams aren't, and it was created by Greece. Fabulous. We've looked at triangles, quadrilaterals, pentagons, hexagons, and found the general rule, which you can use even if you don't remember the algebra. Wow, this stuff is awesome. We've done a little bit of a recap of algebra. Don't forget, algebra, obligate, fabulous stuff. And some examples. We've looked at the difference about whether convex and non-convex makes any difference to the interior angles. We threw out the idea of regular and non-regular polygons. Wow, all this language. Barry. We've looked at the difference between an interior and exterior angle with some examples. And finally, we've done some fabulous examples from the Cambridge Essentials textbook. And I think I'm pretty much done. Don't you just love maths? Now, if you haven't already done so, please do me a favour and subscribe. Yes, there is a circle for you to subscribe. And spread the word. Please tell your friends about this channel. I'd be greatly, greatly appreciative. If not, there's a video loading over there for you as well. I am MaffsGuru, and I'm signing out. I look forward to seeing you in the next video. Take care.